who's back ready to do some absolute value equations? Let's warm it up a little bit here. The absolute value looks like those two little lines on the side of the number. Absolute value is a number's distance from zero, so it's always positive, right? Because if you're at 5, that's 5 away from zero. If you're at -5 on a number line, that's still 5 away from zero. So here we have the absolute value of 15. 15 is 15 away from zero, so the absolute value would be 15. The absolute value of -3 is just +3. It's 3 away from zero. Now here we'd have to do 18 minus 12, which is 6, and then the absolute value of 6 is 6. Now this one we take the absolute value first. The absolute value of -7 is 7, but then you have this negative on the outside, so you just make it negative at the end. 12 minus -12, well, minus negative is really plus positive. 12 plus 12 is 24. The absolute value of 24 is 24. -10 plus 8 is -2, and the absolute value of -2 is 2. All right, so when you are solving absolute value equations, your first goal is to isolate the absolute value symbols. So get everything that isn't in the absolute values to the other side of the equal sign. As soon as you do that, you're going to set up two equations, one with a positive answer and one with a negative answer, and then you solve them. So here we have the absolute value of x plus 5 equals 11. Step 1, isolate the absolute value symbols. So we need to get it down to just the absolute value of x. So we're going to get rid of plus 5 by doing what? Yeah, minus 5. If you do it on one side, do it on the other. So we have the absolute value of x equals 6. This is where you're going to set up two equations. The first one, you just drop the absolute value symbols. X equals 6. And there's nothing to solve. The other one, you do a negative version of the answer. And again, there's nothing to solve there. So these are both answers, which if you put them in the original equation, they both work. Because the absolute value of 6 is 6, and 6 plus 5 is 11. The absolute value of -6 is 6, and 6 plus 5 is 11. Isolate, set up two equations, solve. 2, there we go. Absolute value of t minus 2 equals -1. Add the 2 to both sides. Absolute value of t equals -1 plus 2 is 1. Here's where we'll set up our two equations. One, you just drop the symbols, that's solved, and then one, you do a negative version of the answer. That's solved. And sometimes there's more than just the variable in the absolute value symbols, so there's a little bit more to do, but we'll get there. 3 times the absolute value of n equals 15. You need to get it down to just the absolute value, so you'll divide out that 3, which will leave you with the absolute value of n equals 15 divided by 3 is 5. Here's where we set up the two equations. One with a positive version of the answer, one with a negative version. N equals 5, n equals -5. If you put either one of these back into the original equation, they both work. Now you might notice we always get it down to the absolute value of something equals a positive number, because absolute value can never equal negative. So if you ever got it down to like the absolute value of x equals -4, absolute value is always positive, so you would say no solution at this point, because there's nothing you could put in that absolute value symbol that would come out to -4. All right, here we go. 4 equals 3, absolute value of w minus 2. So pretend like those absolute value symbols weren't there, and you were just solving 3w minus 2. First, you would add 2. 4 plus 2 is 6. And then it would say 3w equals 6, so you would divide by the 3. Same thing here. 2 equals the absolute value of w. Here's where we set up our two equations. W equals 2, and w equals -2. So now we're going to do ones that actually do have more in the absolute value symbols. Absolute value of 2p plus 5 equals 11. First, get it down to where it's just the absolute value symbols on one side, which it is. Then you set up your two equations. One with a positive version of the answer, aka just drop the symbols. And one where you make the answer its opposite. So we'd say 2p plus 5 could also equal negative 11. And why this works is if we can get the inside of this to equal positive 11, absolute value of 11 is 11. If we can get the inside of this to equal negative 11, the absolute value of negative 11 is 11. So we solve them both with the same two steps. We'll subtract the 5. Here 2p equals 6, and here 2p equals negative 16. And then divide out the 2. P equals 3, and p equals negative 8. If you substitute either of these into the original equation, they both work. If we did 3, 2 times 3 is 6. 6 plus 5 is 11, and the absolute value of 11 is 11. If we put in negative 8, 2 times negative 8 is negative 16. Negative 16 plus 5 is negative 11, and the absolute value of negative 11 is still 11. Isolate, set up two equations, and solve. Here, it's isolated, so set up the two equations. C minus 2 equals 6. C minus 2 equals negative 6. Add 2. Add 2. 6 plus 2 is 8. Negative 6 plus 2 is negative 4. Here we go. We've isolated, so set up two equations. Oh, can absolute value ever equal a negative number? Oh, not gonna fool me, Mr. Plant. No. Solution. Now, if you were to solve that, and you solved t plus 2 equals negative 5.5 and t plus 2 equals positive 5.5, you'd come up with answers where when you substitute them back into the original, neither one of them works. So if you can get it down to the absolute values and it equals a negative number, no solution. Here, absolute value symbols are isolated. Set up your two equations. 7d equals 14. 7d equals negative 14. 5 by 7. 5 by 7. 2. And negative 2. Now, I want to take you extreme with this for a minute. We're going to make one up that's a little ridiculous. Let's go with this. First thing, we have to isolate the absolute value symbols. So we have multiplication there, we can divide by 3, but we do that second. First, we got to get rid of that 4. So we'll subtract the 4 from both sides. 3 times this absolute value stuff equals 10 minus 4 is 6. Now we're going to divide out that 3. Divide by 3, divide by 3. Absolute value of 4x minus 1 equals 2. Here's where we would set up the two equations then. 4x minus 1 equals 2. And 4x minus 1 equals negative 2. First, we would add the 1. 4x equals 3. Plus 1 plus 1. 4x equals negative 1. And then we would divide both of those by the 4. So x equals 3/4, 1.75, and x equals negative 1/4, or negative 0.25. If you substitute either of those into the original equation, they both work. We did it, man. We did it.